will see the Faraday's electromagnetic induction. Okay, so in order to understand this, we need to look at the three different laws. So let us start with the first. So what the first law of the Faraday's induction? So here we consider there is one magnet, and here we are keeping one conductor. Okay. So here we have magnetic field. So as per the first law of the Faraday, whenever the magnetic, here we have the conducting loop. So when we are keeping this conductor and this loop both are at the steady position, there is no any change and there is no any current flowing in this conducting loop. But when we are just moving this magnet towards this loop, so what happens? The magnetic field lines or the magnetic flux passing through this loop is changing. When we are just moving away, then again the magnetic field line passing through this loop is changing. Second way, what you can consider, you can vary this loop also. If at the first case the loop is here, if the second case I am keeping this loop here, so the number of loops passing through this closed number of field line passing through this closed loop is different. If I am keeping here, it is different. So what happens when we are just moving, whether the magnet or the loop, the magnetic field line passing through this closed path is varying, and because of this variation, what happens, we have the induced EMF. The magnetic flux variation induces the EMF. Now, in order to understand what amount of magnitude is induced, we have to look at the second law. So, what is the second law of the magnetic Faraday's induction? The second law, that is the EMF, the induced EMF is nothing but the rate of change of the magnetic field with the time. The whatever in EMF is induced, that is proportional, is equal to the whatever the time varying magnetic field lines. Now here we are considering the minus sign, and this minus sign is from the Land's law. So the third law, that is the Land's law. Now as per the Land's law, what's the statement? Current induced in a circuit due to change in magnetic field is directed to oppose the change in the flux. How? And to exert, how? Because how it is? By exerting a mechanical force which opposes the motion. This is a statement for the Lenz law. Let's understand. See here what we saw. First we have considered one magnet and there is one conducting path. Okay, conducting loop. Now here because of the variation in the magnetic flux, due to this variation the EMF is induced. But as per the Lenz law, apart from the electromotive force, we have the induced current. So the induced current is flowing in this loop. In this induced, it is opposing the change in the flux. So this current would flow in a direction in such a way that it would oppose the change in this flux lines. How? By exerting a mechanical force. Say for example, if here we are just trying to keep this magnet towards this loop. So what would happen? When we are just closing it, obviously the field lines are changing, but now the current will oppose. It will induce some mechanical force in a way that it would change. Here it would apply the mechanical force in such a way that it would result here the north pole and the opposing would be the south pole. So the north and south, so now because even after we are moving towards this loop, because of this mechanical force, it is just feeling the repulsion. Second way, if we are keeping here the north and south, and let's consider the loop again, and just we are moving away, then what happens? When we are moving away, obviously the field line passing through this loop is changing, but now it will apply the mechanical force in such a way that here it will result into the south and the opposite would be the north. So here it would feel the attraction. So the Lenz, as per the Lenz law, the current is inducing here. If we are just moving towards, then it is moving the anti-clockwise, then it is the clockwise. So as per the Lenz law, the induced current is opposing the change in the magnetic field line in such a way that it is forcing some mechanical force, it is applying some mechanical force in such a way that it can change the it can oppose the way it is changing. Okay, so this is all about the electromagnetic induction law given by the Faraday. Thank you.